Welcome third graders to the Dallas Independent School District STEM Environmental Education Center. And we'd like to welcome all of the schools that are with us live this afternoon. We have the Dallas Academy with us, Rosa Parks Elementary from Lancaster ISD, Seagoville, Cowart, Bowie, Arcadia Park, and Withers Elementary Schools from the Dallas Independent School District, and Peerfoy Elementary from Frisco ISD with us this afternoon. Thank you so much for joining us. We wish you could be here in person. But since you can't be, we're going to do our best to make you feel like you're here during a virtual field trip today. If you are watching this and have not registered for this field trip yet, you can still do that by going to www.tiny.cc/3-5 registration. Once you get there, you can get yourself or your class registered for this virtual field trip. We just use that information for our attendance purposes. And today's field trip is going to be all about properties of matter. During this virtual field trip, students will observe properties of matter, including temperature, mass, magnetism, and the ability to sink or float. Students will classify matter as solids, liquids, and gases. Students will also predict and observe changes in the state of matter caused by heating or cooling. So we're going to start things off this afternoon by exploring the physical property of magnetism with Ms. Schramm. Next, we're going to look at matter's ability to sink or float in water with Mr. Monroe. Third, we're going to look at how matter can be changed by heating and cooling with Mr. Dominguez. And last but not least, we're going to explore mixtures with Mr. Ramirez. While we're doing all of that, you can ask us questions, but since this is a virtual field trip, the way you ask a question is you go to www.tiny.cc/question-answer, and you'll fill out a very short form, submit your question to us. You can ask any question you like regarding properties of matter. You can ask as many questions as you like, and we'll do our best to answer all of them in the time that we have with you this afternoon. So let me stop sharing my screen now and turn things over to Ms. Schramm, who's going to get us started with magnetism.
Hi, everybody. It's me, Ms. Schramm. Special shout out to any little Cowart Panthers over there. I'm happy to see that you all signed up. I missed you. Everybody else, I'm so glad to have you. I wish I could see your faces, but here we are. So let's get started with our magnetism. All right, we'll get this in full screen. All right, so today you will be discussing magnetism with me. You'll be able to measure, test, and record properties of matter, including magnetism. So mysterious magnets. Our main question today is going to be, how do magnets interact with other objects and one another? The first part of that question is, how do magnets interact with other objects? So I've collected some objects around my classroom that you might have at home or in your classrooms as well. So I'm going to look through all these items, and we're going to see what they do when you place a magnet near them. So let's see, I'm going to stop sharing. Boop. All right, and let's see. So my bucket of items. First, we have a stone. Now I'm going to bring my bar magnet in. And it's got a red side and a blue side, but more on that later. And I'm going to bring my magnet close to the stone and see if it interacts. You could do this at home with a refrigerator magnet. Maybe you have one of these large U-shaped magnets, but I prefer to use the bar magnet. So if I bring it up, there's no interaction with the stone. That must mean it is not magnetic. My next item, let's see. I have a pipe cleaner. Let's see. Oop. The pipe cleaner gets picked up by the magnet on both sides. So the pipe cleaner must be magnetic. A little cut of wood. No interaction. Non-magnetic. See, I have a marble. Once it stops rolling, no interaction means non-magnetic. Next, we have a paper clip. And right away, that gets picked up by the magnet on both sides. All right, let's keep going. We have a crayon. No interaction. A cat, too much interaction. A soda can. No interaction, non-magnetic. A ring magnet. That is definitely magnetic. And let's see, a compass. So if you look closely at the compass, there is on the little dial is a red side and a black side. I want you to pay extra close attention to the dial of the compass, the red side, when I bring the magnet near. As you can see, the magnet is interacting with that dial. It is making the compass turn. Now, the compass is a tool that's used to tell which direction you are traveling. The compass interacts with the Earth, which is one giant magnet, to tell you which way you're going. The red side, always points north. Okay, now our last object is just a petri dish with iron filings. So this is iron that has been filed down or kind of like shredded so that it's just like little iron dust. Now, so I don't make a mess, I'm going to take my magnet and put it underneath the petri dish and we'll see what happens. As you can see, the iron is attracted to the magnet. It follows that magnet around and I'm able to move the iron filings without touching them just by using the magnet. Now, if you've ever played with that toy, Wooly Willy, it has like a man's face and you can use iron filings to make a little beard, and that's what it's using. All right, so to sum that up, let's look at our little chart. Present. All right, so when we look, the items that were non-magnetic were the marble, the wood, the Coke can, the crayon, and the stone. The items that were magnetic were the pipe cleaner, the paper clip, the compass, the ring magnet, and the iron filings. So I won't be able to hear your answer, but I want you to tell a friend next to you, what is it that all those items that were magnetic have in common? What is it that they have in common that makes them magnetic? I'll give you a couple seconds to tell your friend. You may have noticed that all of those objects contain metal. But wait, not all metals are magnetic. That Coke can is made of aluminum. Aluminum is not magnetic. The only metals that are attracted to magnets or interact with magnets are metals that contain iron, cobalt, or nickel. Okay, not nickel like the coin. Nickel is the kind of metal. So iron, nickel, and cobalt interact with magnets. All right, let's look at our next part of the question. How do magnets interact with one another? Well, we use that magnet ring, and that was attracted to the bar magnet. But let's see what happens when we take two bar magnets and bring them close together. So I have, let's see, I'm gonna stop sharing so we can see up close. But first, I want to compare or see how two magnets interact when I put both north ends together. So I'm gonna put these at the table and let you see. So I have my north end facing in, that is the red, and I'm gonna bring in another magnet with the north end facing in and see what happens. All right, if I come straight on, you can see it is pushing the other magnet away. They are repelling. Now, if I hold them up and I try to push them together, it's really hard. I cannot get them to connect. All right, and the stronger the magnet is, the harder it would be to make them connect. So north and north repel each other. They push apart. Now, if I turn this one around and bring this south end towards the north end, let's see what happens. I bring it straight in. I'll do it one more time without my hand in the way. Whoop. They are attracted. They snap right together. They are attracted. And if you were holding these two magnets, you will be able to feel the attraction. They pull right together. All right, so our last little test is to put the blue side in. So that's our south pole. Bring the other south pole towards it and see what happens. Oh, sure enough, it pushed it all the way around and made it spin so that it could attract the north end. So the south side and the south push apart. They repel. All right. So how do they interact with one another? Well, when the two sides are the same, when they are both north poles, those will repel. They will push apart. When you have the opposites, the north pole and the south pole, they will push together or pull together, attract. And when you have two south poles, once again, they are the same. They are going to repel. So with magnets, opposites do attract. Briefly, I want to show you the magnetic field. So we cannot see what is pushing and pulling, what's attracting or repelling the magnets because it is invisible. The magnetic field cannot be seen with our eyes. But this picture is showing one of those bar magnets, just like I showed you, with iron filings like we used before, scattered around the magnet. So you can see what the magnetic field would look like if we could see it with our eyes. There's a drawing right here that I wanted to show you that has those lines. That is a visual representation of the magnetic field. Even though we can't see it, we know those forces are pushing and pulling in those directions from the South Pole around to the North Pole. Now that blue circle is showing us that magnetic field. So that is the area that you would have to bring an object into for it to interact with that magnet. So like when I had the magnet on the table, it didn't interact until I brought that magnet near. The stronger the magnet, the bigger the magnetic field. So that leads us back to the compass. The compass points always to the North Pole. Our Earth is a big, huge magnet with a big, huge magnetic field. And that compass that we have interacts with the magnetic field so that we always know which way is north. All right. So just lastly, the vocabulary that we covered was to attract means to pull together. Repel means to push apart. And magnets are attracted to metal objects that contain iron, nickel, or cobalt. So I have a challenge for you, which is a magnet search. So you can explore your classroom to find more examples of magnetic and non-magnetic objects. You can do this in your classroom or maybe even at home. Like I said, you don't have to have a fancy bar magnet or a fancy U-shape. You could just take one of those refrigerator magnets or something from the whiteboard if your teacher gives you permission, and you can go ahead and explore and see how magnets interact. All right, thank you for visiting. Enjoy the rest of your field trip.
Thank you, Ms. Schramm. And the first question comes from Alvin at Arcadia Park. Is iron in the ground magnetic? Yes, it is. In fact, it's iron in our liquid outer core that makes the Earth act like a giant magnet. And then Madeline asked, does a magnet have metal inside of it? It does. It's a iron ore called magnetite, or another name for that is lodestone, but it is a metal. Giselle asked, how does a magnet attract metal? Metals like iron have electrons that'll easily align to a magnet, and that's what allows them to become like a magnet and move towards a magnet. And then Angela asked, do magnets only interact with iron? You asked that before Ms. Schramm got to the end of her presentation, but she just said that it's iron, cobalt, and nickel. So it's those three metals. And why is the wood non-magnetic? Sophia and Camila asked, and wood is not magnetic because wood's electrons do not easily align to a magnet like iron's electrons can. And that is why wood is not attracted to a magnet. All right, now we're going to look at another property, which is sinking and floating with Mr. Monroe.
Good afternoon, students. My name is Mr. Monroe, and we're going to be looking at the properties of matter as far as the ability to float or to sink. Now, the ability to float, there's a key word that I'm going to be using a lot, and that is the word buoyancy. Anything that has buoyancy has the ability to float. You know, I've been curious about a lot of objects around me, especially out here at the Environmental Ed Center, where we have so many different types of trees, so many different types of plants. I've often wondered how some of those plants and trees got here. Well, I've learned a little bit about how seeds get moved around all over our planet. We call that seed dispersal. And one such way is by water. That means that evidently seeds have the ability to float or to have buoyancy. So we're going to be testing some seeds, and then we're going to be testing some other objects that are made up of different types of matter. Now, we know that matter, if it's made up of matter, then it is made up of the building blocks of matter, which is atoms. Everything that is made up of matter is made up of atoms. And some of those atoms, those little bitty tiny particles that make up matter, sometimes they are really packed together in a tight form. Compactness, that's another big word for third graders. Compactness means that the particles that make up that matter are tightly packed together. In other words, they are dense. Later on, you're going to be learning about a term that you'll be familiar with by the time you get out of the 5th grade, and that is the term density. That is how many atoms and how tightly they are packed together to make up that type of matter that you might be studying. So let's go ahead and test some of these seeds. Well, I'm going to start out by testing a pecan. Now, I don't know what you guys realize, but a pecan is a seed that will eventually, if conditions are just right, grow a pecan tree. So I'm going to put a pecan in this aquarium with water. Now we can test other types of liquid with the buoyancy with other objects. But today we're using just plain old H2O, water. Here we go. Well, that pecan is buoyant. It's floating, isn't it? It didn't sink. It didn't go to the bottom. So that would be one seed I know that probably could get moved around if we had high water or flowing water. It would carry it to some places, and if conditions were just right, it might even grow a pecan tree. How about an acorn? Now, over in the Post Oak Preserve, where we have nature trails, there are a lot of trees that produce acorns as seeds. And I've often wondered how some of those seeds got over there. I know that some animals have probably caused those seeds to get there, but I believe water has also been a factor. So let's see. Yep, that acorn is floating right on the surface of the water. So water, if it's moving, it could carry this acorn somewhere different where it might even grow an oak tree that would produce the acorn. Well, I've got a weird looking seed here. It's spiky. We call them cuckabirds. In fact, this morning we were doing some sampling out at the pond, and our net, as we brought it through the water, it collected a lot of these seeds. And no doubt, this probably has a little buoyancy to it because it definitely is a lot of cuckabirds in our pond. Yep, there it is. It's floating right on the surface. Now, as I go through these different tests with these different objects, students, I want you to remember some of the things that float and some of them that sink, simply because your teacher might even ask you some of the questions about these objects later on. So pay attention now. Well, how about this? Now, this is really weird. This is cotton. You guys know that cotton grows on a plant, right? Well, inside this cotton, you can feel little knots that are actually seeds of the cotton plant. I'm going to drop this in here, and we know because this is cotton, kind of got a good idea what's going to happen because of how it feels and how it looks. We can make a good guess that it's probably going to float. And I guess a good scientific guess, we could use a scientific word to describe that, and that is the word hypothesis. So here it is. It's floating. Even more so, it has more buoyancy than the pecan or the kookaburra had. And simply, or the acorn, simply because I would imagine all this cotton. So it could get moved around, right? One more cluster of, well, not a cluster, but a pine cone. And inside the pine cone, there are seeds. So let's see what the pine cone does. Yeah, it's buoyant too. That means it has the ability to float. Well, I can tell you some things that probably don't have buoyancy. Those things would be densely packed. The atoms of those objects would be so densely compact that they would be denser than what water is. You'll learn all about that later on, but I'm going to start out. How about just a simple marble? You guys know what marbles are, don't you? We used to play games when I was young, shooting marbles. Well, let's see what happens. It went to the bottom immediately. So it does not have any buoyancy. It sunk to the bottom. How about a rock? Let's check out this rock here. Let's see what happens here. Oh, it sunk to the bottom also. You know, I like to fish every once in a while. And for me to get the bait down to where the fish are in the water, I use a lead weight. I've got a lead weight here. We know that that's pretty heavy. So the atoms that are in this metal called lead are densely packed. And so, wow, that went straight to the bottom too. You know what? I've got a magic rock here, and it doesn't seem like it's as heavy as that lead sinker or that other rock. Let's see what happens with it. Whoa, look at that. Can you believe it? It's a rock that floats. Well, I can tell you, one of the reasons that rock is floating, simply because of its density or the compactness. The minerals that make up this rock, because we know rocks are made out of minerals, the atoms are not so compact. They're not densely packed. So I will tell you, there are little tiny holes in this rock that allow for air to get trapped in it, and it helps it to do what? Have buoyancy or float. How about a piece of wood? What do you think? Give your teacher a hypothesis. Mention to her, do you think it's going to float or sink? Let's see. Oh, it floats. So it does have buoyancy. Wood will float. And I'll tell you something else. You heard me say that I like to go fishing. Sometimes when you put your line in, you want that line to be kind of held up to a certain depth in the water. So you will attach a float. Look at that float. Now, that float would also tell you whenever there's a fish tugging on the line. It probably would pull the float under, okay? Now, these are all things that right now are not really alive, right? I've got a question that I want to answer to myself or find out for myself. And that is, I've got an animal over here called a crawfish or a crawdad. And right now he's trying to pinch me. So I want to check him out. I know that this guy can swim, but he doesn't do a lot of swimming. So I want to see if he will float or if he will sink. Now remember what floating is. It's buoyancy, the ability to float. And sinking, hey, you just going to the bottom. Let's see what he does. Oh man, you see him? He's walking on the bottom. Let's see if I can, whoop. I don't know whether I ought to mess with that guy. He's ready to fight. You see him? What's up? Oh man, that's too much. Well, I hope you guys have learned it. Oh, one more thing, guys. You know, I want you guys to be safe. So let me pass this on to you. If you're boating or if you're around water and there's a chance that you might be involved in an accident where you might want to protect yourself and be safe, always wear a life jacket. Now, a life jacket has buoyancy. It has the ability to float because it's made up of material that doesn't have compactness. It's able to have buoyancy. The material that makes this up, the atoms are so densely packed, and I used the wrong word a minute ago, it is compact because it will keep you afloat, even though if you didn't know how to swim, you might sink. If you have one of these on, it's going to keep you floating on the surface, like many of the items that I just showed you that have buoyancy. All right, guys, I hope you have a good time on the rest of your virtual field trip with us today. I'm going to turn it back over to Mr. Broughton. So if any of you have any questions, I bet he can answer them for you.
Thank you, Mr. Monroe. We got two questions. First, Madeline asked, is the water in the tank heavy? And yes, it is. 1 gallon of water weighs 8.34 pounds. And I think that tank is a 10-gallon tank, and it looked like it was about 3/4 of the way full. So it has maybe like 7 gallons of water in it, 7 or 8. And if we said 7 times 8 would be 56, but it was 8.34. So I'm going to estimate that that tank weighs about 60 pounds, which is pretty heavy. And then the next question from Elijah was, does a bottle of water float or sink? I think that would depend on what the bottle is made out of. If it was glass, I would say it would sink, or if it was metal, I would say it would sink. If it was plastic, maybe it could float. You'd have to test it out. That'd be a good experiment to do in your class or at home. And then why do the seeds float? If the seed is less dense than the water, it will float. If it is more dense than the water, it will sink. So now we are going to move on to that investigation with heating and cooling and how that changes matter with Mr. Dominguez.
Hi guys, it's Mr. Dominguez here with the EEC, and I'm here to talk to you about heating and cooling and how those two things affect matter. As you guys may have already been told, everything around you is made out of matter, including Kiwi right here, the bearded dragon, your desks, your pencils, everything you can think of is made out of matter. Now, why do I have Kiwi here as my helper today? Well, I wanted to showcase a cold-blooded creature because I think they are very interesting because they rely on the environment to properly regulate their bodily functions. And I'm talking about the heating and cooling elements of the environment. So for example, the sun warms her up and keeps her bodily functions going. And she right now is pretty warm, so that's why she's active. But when she cools down, she slows down. Now, that's one example of how heating and cooling affects something made out of matter. Now, I'm not going to be using Kiwi here for my demonstration today because I'm going to be using a little bit of fire to help you understand how heating and cooling affects the properties of matter, but only with abiotic things. Abiotic means non-living things. Now, Kiwi's biotic, which means that she's a living thing, and we're not going to subject her to any experiments today. Right, Kiwi? She wouldn't like that. So, wave bye to Kiwi, guys, and I'll be right back. Before we begin our experiment, let's review the different states of matter. There are solids, liquids, and gases. And while the examples before you have different physical properties, it's all water. So how did we get from a hard, blocky solid to a wet, clear liquid to a invisible light gas? Antes de comenzar, nuestro experimento, repasemos los diferentes estados de la materia. Hay sólidos, líquidos y gases. Y aunque los ejemplos anteriores tienen diferentes propiedades físicas, todo es agua. Entonces, ¿cómo pasamos de un sólido, duro, en bloques, a un líquido transparente, a un gas invisible? Maybe some of you spotted the clues. One of the ways we can change the physical properties of matter is by heating and cooling. Tal vez algunos de ustedes vieron las pistas. Una de las formas en que podemos cambiar las propiedades físicas de la materia es calentando y enfriando. So, I have my thermometer here. This was the big clue. And as you can see, I've already started to heat up some water, some liquid water, and some solid water or ice cubes. And as you can see, we already have a little bit of change. So I have some solid water melting into liquid water. Now, this just started to heat up, but you can see some very small bubbles. So this water will eventually reach its boiling point and it will start bubbling and release gas, or well, turn into gas. Now, we don't want to be here forever, so I'm going to speed this up. Alright guys, so to speed things up, I came to my microwave, one of the best tools that you have in your own home to heat things up. And as you can see, we see a liquid turning into a gas simply by heating it. So I'm going to open this microwave door up so you can get a better view of what's happening. So, you guys see all that gas? I do. So we went from a liquid to a gas. Alright guys, so now that we've seen what happens when we heat up matter, how the properties change, how we go from a solid to a liquid to a gas simply by heating up the matter, I want you guys to ask yourselves, how do we go backwards? How do we go from a gas to a liquid and then to a solid? Quiero que se pregunten algo. ¿Cómo podemos convertir a un gas, a un líquido y a un sólido? You guessed it. We have to cool things down. I want you guys to picture this. I want you guys to think about a cold can of soda. So I have a can of Diet Coke right here. And I want you guys to think of what happens when a really cold can of soda is sitting out in this Texas heat. Well, suddenly you have liquid, little droplets of water forming outside of the can. And it's not the liquid inside of the can that's leaking out. It's actually the water vapor around us that is turning back into a liquid. And you can actually see this right now. You can actually see this. Do you guys see this? You guys see a little bit of, here, I'm gonna run my finger through this can of soda. Maybe you guys can see that. You guys see that? There's some water droplets already forming on the outside. And that's not the liquid inside. That's actually the water vapor cooling down and turning back into a liquid. You guys see that? I put a little smiley face right there. Let's see if I can draw a smiley face. That's all liquid right there. And if we were to take that liquid, if we were to gather it, and put it in a container and freeze it, cool it down a lot, you'd get a solid. So next time you guys pop open a can of soda and you guys see that happening, those water droplets forming in your on your soda, think about how heating and cooling affect matter. I hope you guys enjoyed this portion of your field trip. I will see you guys next time.
Thank you, Mr. Dominguez. Daniel asked, is the earth matter? And yes, it is. The earth is made up of solids, liquids, and gases, which are all matter. And Riley asked, is the sun made of matter? And yes, it is. The sun is made of extremely hot gases. But again, gases are matter. So the sun is also matter. All right, now we are going to explore mixtures with Ms. Ramirez.
Hello, my name is Ms. Ramirez, and we're going to be learning about mixtures. So before we get started with our slides, I have some examples of common mixtures that we use here at the Environmental Center. The first mixture is actually a bird seed mixture, and you can see all of the different substances that come together to create this mixture. So see if you can point some of those things out. We have some sunflower seeds, safflower seeds, peanuts, and then we also have some freeze-dried dead mealworms inside this mixture too. And we use this a lot outside to help feed some of our birds. Another mixture that we use a lot, especially out on the farm, is with our livestock, our poultry. So the chickens, this is some chicken feed. It's another mixture of seeds and corn and oats and also some freeze-dried dead insects. And some of those dead insects would be things like the mealworms. So these are live mealworms, but inside our bird feed, they're actually freeze-dried and they're no longer living. But I actually have an animal that loves to eat these guys. So I'm going to bring her out and I'm going to give you some clues to who she might be. So listen to those clues. This animal has 2 legs, a beak, a body covered in feathers. She has wings. She's an omnivore, so she eats both meat and plants. And the easiest clue of all, she lays eggs that you guys probably eat. So go ahead and think about what animal this is, and I'll go pull her out. So make your guess. And if you've watched us before, then you probably remember her. This is Pepper the blue silky chicken. And she gets that name because she has a pretty blue patch of skin surrounding her ears. And she loves to eat those seed mixtures that I showed you guys earlier. She also loves to eat salad mixtures too. So I'm going to go ahead and put our friend Pepper up so she can go play. And I have a quick little presentation to show you guys. So I'm going to share my screen with y'all and we'll get started. Hopefully by the end of this presentation, you'll be able to answer these 2 questions. The first question is, what is the definition of a mixture? And the second question is, give at least 2 examples of tools that can be used to separate a mixture. So keep those 2 questions in mind as we go through the presentation. And over here on the right, you see one of my favorite mixtures to eat, and this is a poke bowl. And it's actually Hawaiian, and it means chopped or cut and sliced into pieces. And I love to eat poke bowls with crab and chicken and all those mixed vegetables as well. So think about what kind of mixtures you enjoy eating. So speaking of mixtures, a mixture is just a combination of 2 or more substances that keep their individual identities. It's important to note that neither substance has become something new, and most of these mixtures can be separated fairly easily by using some science tools. So let's look at another video of some mixtures here at the Environmental Center. The first is a mixture of cat food with one of our cats, Stripey. I also have 2 of my bunnies eating a salad mixture. And of course, we know that these are mixtures because each of those individual items can be easily separated. They keep their own identities. And then here in a little bit, you'll see our friend Pepper that you saw earlier eating her mixture of those mealworms and her fruit and veggie mixture as well. Here we have some box turtles eating their salad mixture. Again, you can clearly identify each of those components of the mixture. And then I have a little challenge question for y'all. Think about how can I separate this mixture of paper clips, pebbles, sand, and tree bark. So think about the physical properties of each of those components and how can we use those properties to help us separate this mixture. Teachers, feel free to pause this video for discussion and brainstorming time, but I'm going to go ahead and explain how I separated this mixture. Now I'll give you guys some clues in just a little bit. I'm going to show you some examples of science tools that might be helpful in separating this mixture of items. So again, as a scientist, we know that those physical properties you learned about with the other teachers can help us separate this mixture. So I'm going to use a magnet, a sieve, and a container of water. So think about how can we use those to help us separate that mixture. So the first thing we're going to do is how can I separate the paper clips from the other materials in this mixture? And I'll give you guys a hint. Miss Ram went over an important property, and that is magnetism. So we can use the property of magnetism to help us separate those paper clips. So of course, I'm going to use a magnet to help us take out those paper clips. So once those paper clips are taken out, all I'll have left are the rocks, the bark, and the sand. So think about our next question is, how can I separate the smaller sand from the other materials? So in this time, we're going to use the physical property of size, and we're going to use that screen mesh to help us sort those objects by size. Now notice the sand is the smallest, and so the sand will fall through that mesh net. And once all that sand falls through, then all we'll have left will be the rocks and that light tree bark. So think about, when have you used a sieve or a screen to help sort something by size? I know I use it all the time when I cook pasta, because I'm sorting my pasta from the water. So my next step is, how can I separate the heavier rocks from the lighter bark? So think about, what tool can I use next? And we're actually going to use the physical property of density. So we're going to use the ability to sink or float to help us sort those last two remaining items. And as you can see, those heavier rocks will sink to the bottom and the lighter orchid bark will actually float. So now we have successfully separated all of those components within the mixture. We didn't use our hands to physically sort them. Instead, we used those science tools. So in our next slide, I have a scavenger hunt for you guys. I would like for y'all to find 5 examples of mixtures at your home or your school and explain why each of them is a mixture. I also have another thinking question here. I have a picture of a pot and it has water in it. If you add salt to that water to make it salt water, can that be an example of a solution or a mixture or both? So kind of explain your reasoning behind what that image is. I'm going to go ahead and stop my screen share. And then I have one last thing before you guys go. I have another mixture. This one is a mixture of oil and water that's been colored with food coloring. Super simple. You guys can do this at home with just vegetable oil and water and food coloring. But think about, how can I separate these two? And you can also, I know you guys are probably familiar with this if you play with sensory bottles or those sensory toys. Think about if you make one, how can you then go back and separate all of the components within that sensory bottle as well? So that's all I have for you guys on mixtures. We're going to give it back to Mr. Werman Mr. Broughton to answer any questions.
Thank you, Mr. Ramirez. The first question that was asked by Adam was, how do chickens lay eggs? And I am not exactly sure how a chicken lays an egg, but I do know if you give chickens food with calcium and protein, it helps them lay more eggs and stronger eggs. Alvin asked, is Pepper a boy or a girl? Pepper is a girl. Jocelyn asked, is Earth a mixture? Earth is made up of mixtures and solutions that are in different parts of the world. Like, for example, there's a mixture of animals in a forest, but the ocean is a saltwater solution. Is slime a mixture? No, it is a special type of mixture called a colloid. Why does Pepper eat mealworms? Asked Jacob. Mealworms have protein that help Pepper stay healthy. Angela asks, can mixtures have liquids and solids in them? Yes, they can. If you mixed rocks and water, that would be a mixture that you could easily separate. And Ivan asked, do chickens like to eat apple slices? Yes, they do. They like to eat lots of different fruits and veggies. Okay, I'm going to share my screen here real quick with you to do a quick recap of what we did. This afternoon's field trip was all about properties of matter. So first we explored the property of magnetism with Miss Schramm. Then we looked at different objects' ability to sink or float in water with Mr. Monroe. Next, we saw how heating and cooling can affect materials and matter with Mr. Dominguez. And we just explored mixtures and how to separate different mixtures using tools with Mr. Ramirez. Thank you so much for joining us this afternoon. We appreciate you taking the time to learn about properties of matter with us. We hope you enjoyed this virtual field trip, and you can let us know whether you did or not by going to www.tiny.cc/3-5 feedback and filling out a short feedback form. We use that information to improve what we do out here, and we are going to have another virtual field trip for third graders in about 3 weeks. So we hope to see you again then. Have a great rest of your day, and we'll see you next time. Goodbye.